Hi, you are welcome to Guide Academy. In this video, we are going to look at how to find the domain of any function. The domain of a function consists of all possible values of x for which the function is defined. This means that all possible values of x, which makes the function undefined, is not part of the domain of that function. Now, what is the condition for a real number system to be undefined? We have two conditions. The first one is that that system should not be divided by 0. So for example, if you have say 1 over 0, it means you have an undefined system. Or if you have a function of x plus 1 all over 0, it means the function is undefined. The next condition for a real number system to be undefined is when there is a square root of a negative number. For example, if you have square root of negative 1, then it means that the function is undefined, since the result of square root of negative 1 is I, of which I is a complex number. So these are the two conditions for which a function is undefined. So we are going to be applying these two concepts in finding the domains of all the types of functions that we have. Now, let's look at how to find the domain of polynomial functions. The domain of every polynomial function is x is such that x is a member of all real numbers. So anytime you have any polynomial function, whether it's a linear function, a quadratic function, a cubic function, and so on, the domain is x is such that x is a member of all real numbers. This is because from our initial conditions of a real number being undefined, you realize that for each of the functions here, there is no denominator of 0, which can cause a function to be undefined. So for example, with the first question, for instance, 3x minus 7, the denominator is 1. So 3x minus 7 is the same as 3x minus 7 all over 1. So it means that this denominator of 1 is not 0. Hence, we cannot say that this function is undefined. Also, when you look at the second conditions for which a polynomial, for which the domain of a function is for which the domain of a function is undefined, you realize that you need a square root, you need a negative sign inside a square root. For example, a negative number inside a square root for you to get undefined. But you realize that in these expressions or in these kind of polynomial functions, there are no square roots anywhere, which means that you cannot have an undefined function when it comes to polynomial functions. So it means that for all these examples, so for example, let's solve the first question. F of x is equal to 3x minus 7. The domain is x is such that x is a member of all real numbers. Okay, since there's no particular value that when you put here, you get an undefined function. For example, if you put, for instance, x is equal, so let's say let x be equal to, say, 7 over 3. F of x will be equal to 3 into bracket 7 over 3 minus 7. 3 cancels 3, and then you have 7 minus 7, which gives us 0. 0 is a real number. It's not undefined. Okay. So this means that this is the domain of this particular function. X is such that x is a member of all real numbers. To plot this on a number line, you can have the number line in this format. Number line has negative infinity to positive infinity. Since x is such that x is a member of all real numbers, it means that the range of values applies everywhere. So to write the domain as an interval notation, you have from negative infinity to positive infinity. Notice that I used parentheses and not square brackets. We are going to understand why I didn't use square brackets, but I'm using parentheses later in the video. Okay. So from this whole idea, we can see that for all of these functions, the domain is x such that x is a member of all real numbers. X is such that x is a member of what? All real numbers. X is such that x is a member of what? All real numbers. And x is such that x is a member of what? All real numbers. Since these are all polynomial functions. Okay. Now let's look at the next type of functions that we have. The next type of functions that we have are rational functions. Okay, rational functions. Notice that all these types of rational functions that we have, there are no square roots. Okay, so it means that the idea of our function being undefined, when we have a negative number inside a square root, for example, -1 inside a square root to be undefined, will not apply what here. Okay, will not apply here. But you realize that when you look at all these functions, they have a denominator. And from our first condition, we are saying that we don't want the denominator to be equal to 0 for the function to be what? Defined. So for a rational function to be defined, so for a rational function to be defined, it means that we should have the denominator. We should have the denominator not equal to 0. Okay, so this is the idea that you are going to use to solve the domain of rational functions. Okay, so now let's find the domain of all the rational functions that we have here. Our first question is f of x is equal to 5 all over x minus 2. So since this is a rational function, what number can we put inside this expression to make this whole expression what? Undefined. So we are saying that, so now since this is a rational function, we set the denominator what? Not equal to 0. So you can say that x minus 2 should not be equal to what? 0. Okay, so from here you can say that x should not be equal to what? 2, because you take the 2 to the right hand side of the equation. So it means that the domain is x is such that x is not equal to what? 2. Or some books can decide to write it this way: x is such that x is a member of all real numbers except x is equal to 2. So notice the difference. For the first type, x is such that x is not equal to 2, right? Because if x is equal to 2 and we put it inside this equation, we are going to get 5 over 2 minus 2, which is the same as what? 5 over 0, causing this function to be what? Undefined. So it means that the range of values that will make the function defined should have all real numbers except x is equal to 2, or where x is not equal to what? 2. So that's how to find the domain of this particular function. So to write this, to represent this on the number line, you can have the number line, you have your negative infinity to what? Positive infinity, and then you have your 2 in the middle. Okay, we are saying that it should not be equal to what? 2. So you can have an open circle, and then since it should not be equal to 2, it means that it can range from any numbers to negative infinity or any numbers to what? Positive infinity. Okay, so this means that the domain of the function can be written as an interval notation by writing it this way. So to write this as an interval notation, so they can also tell you find the domain of a function, write your answer as an interval notation. Okay, so for the interval notation, you notice that you have all values ranging from negative infinity to the number before 2. Okay, and then from the number after 2 to infinity. So this is how you write it. You write it using parentheses from negative infinity to what? 2. And I'm going to use parentheses. Okay, now if 2 was included as part of my data set, I would have written it this way: square bracket, which means that the 2 is included in my interval, right? But since 2 is not included in the interval, because we are saying that we should have any value of any row number, but then we shouldn't have 2, then I'm going to use what? Parentheses. Okay, union, okay, union. Now 2 to what? Positive infinity. Notice that also this 2, I used a parenthesis instead of a bracket, because instead of a square bracket, because the 2 is not included in the interval. Okay, so this is how to find the domain of this particular function. This is the domain, this is the interval notation, this is the number line. Okay, let's look at the next question. We have a lot of questions to solve today to aid your understanding. Okay, so now let's look at the next question. Our second question is f of x is equal to what? X plus 3 all over x minus what? 7. Now you notice that this is also a rational function, right? And then for rational functions, what we do is that we set the denominator equal to what? Not equal to what? 0. Okay, because for here, the reason why we are only using the denominator is because for the numerator, there is no value that you put at the numerator. There's no real number that you put at the numerator to make the function what? Undefined. If you put 0 here, you get what? 3. If you put negative 3 here, you get negative 3 plus 3, and then you get 0. Okay, that's why we only focus on the denominator, because that is what can result in the function being what? Undefined. So for the function not to be undefined, then we say that x minus 7 should not be equal to 0. And then we can find x, and then we say that x is not equal to what? 7. Then from here we can say that our domain is x is such that x is not equal to 7. Or just as some books will write, x is such that x is a member of all real numbers except x is equal to what? 7. Except x is equal to what? 7. We can also represent this in a number line. Very simple. Negative infinity to what? Positive infinity. We have 7. We have an open bracket since 7 is not included in the interval, because we don't want anything equal to 7. So we have an open, circle. And then we can have all values ranging from negative infinity, and then all values towards what? Positive infinity. So if you want to write this as an interval what? Notation, you can write it as from negative infinity to what? 7 union 7 to what? Positive infinity. Okay, so that's how we solve rational functions. I believe that from this one we are getting the idea of solving rational functions. There are so many functions that we are going to be talking about, so stay glued to your seat and let's proceed. Our third question is f of x is equal to 3x minus 8 all over x squared minus 9x plus 20. So what we do is that for rational functions, we just set our denominator equal to what? 0. Okay, kindly note that for this type of rational functions, they have no square root. whatsoever. That is why our square root idea of having a negative square root does not apply here. Okay, so now once we have set the denominator equal to 0, from here we have not equal to 0. Okay, not equal to 0. Okay, not equal to 0. Once we have this, we have a quadratic equation. We can solve it as a quadratic equation. Now when we are looking for factors of 20 that will add up to give you negative 9 and multiply to give you 20, I think we'll have -4 and -5, right? So from here we can say that x minus 4 can have two expressions multiplying x minus 5 is not equal to what, 0. And then from here we can set each of them not equal to what, 0. X minus 5 not equal to what, 0. So it means that x is not equal to what, 4, and x is not equal to what, 5. So or, okay, because the quadratic function. So it means that for this one we can see that the domain is x is such that x is not equal to what, 4 or what, 5. Or just like some people can say, x is such that x is a member of all real numbers except x is equal to what, 4 or 5. Okay, that's how to solve this particular equation to find the domain. Okay, now let's look at how to represent this on a number line. So we have our number line, we have our negative infinity to what, infinity. Our values that we have are what, 4 and 5. So you can have 4 here, you can have what, 5 here. That's saying that they are not included. 4 is not included, so you have an open bracket. 5 is not included, you have an open bracket. Okay, since these are the only ones on the number line which are not included, we can have values in this range from here to here, values in the middle range, and then values from 5 to infinity, but not including the 5 itself. Okay, I believe everyone is getting an understanding of this. So from here to write the interval notation, you can simply write it as, we have three regions. This particular region, we have this particular region, we have this particular region, and we have this particular region. So we have to combine all of them using a union sign. Okay, so from here we can say that we have negative infinity to 4 union 4 to 5 union 5 to infinity. Okay, so this is our interval notation, this is our number line. Okay, I believe everyone is getting the concepts behind what we are doing. Okay, this is very simple math. I believe everyone is getting the concept. Yes, so we'll solve more questions, and then by the time we are done, anytime you see any domain question of whatsoever form, you will still be able to tackle it. All right, so let's look at the next question. So our next question is the fourth question. Our fourth question is f of x is equal to what, x squared all over x squared plus what, 9. Okay, so for this one, is a rational function. It doesn't have any square roots. What we do is that we equate the denominator not equal to what, 0. And then once you have x squared plus 9 not equal to 0, we ask ourselves, so what number do we put inside this expression to make this function what, undefined, right? You realize that for this particular one, you're not going to have any number that when you put into this x squared plus 9, you get undefined, or you get the value to be 0. Okay, for example, if you put -3 here, you get -3 squared is what, 9 plus 9, which is equal to 18. This is not equal to what, 0. Okay, so it means that for this particular function, all numbers, all real numbers, the domain is all what, real numbers, all real numbers, because there is no specific value that when you put into this equation can make this equation undefined, or can make the denominator of this equation equal to 0. Okay, so x is such that x is a member of what, all real numbers. You can represent this on a number line as simple as ABCD, negative infinity to infinity, and then you can have the numbers ranging everywhere. So you can have interval notation being written as negative infinity to what? Infinity. Okay, so this question is very simple. So let's look at the next question, our fifth question. Okay, our fifth question says f of x is equal to what? 2x minus 3 all over x squared plus 4. Okay, so for this particular question, it's also a rational function. What you need to do is that you need to set the denominator equal to 0, and then you check to see if there are any numbers that when you put into this can give us what? 0. Okay, so x squared plus 4, you notice that there is no number that when you put into this can cause the function to be 0, and then cause the denominator to be to make the function undefined. Okay, yes, so for this one also, x is such that x is a member of what? All real numbers. Number line is the same as the initial one, have all the range of what? Values. Interval notation is from negative infinity to positive infinity, as simple as A, B, C, D. Now let's look at our sixth question. Our sixth question is f of x is equal to 2x plus 1 all over x squared minus 16. Okay, so since we have no square roots, we don't have to worry about the condition of a square root, but we have a denominator, so we can worry about the denominator being 0. So we say that x squared minus 16 should not be equal to 0. From here, difference of two squares, if you have a squared minus b squared, is the same as a minus b multiplying with a plus b. Okay, so this applies. So you can see that let me clean this side. This is the same as x minus 4 multiplying what? Sorry, let me start from the basics. So you can see that here is x squared minus what? 4 squared not equal to what? 0. So from here you can have x minus 4, x plus what? 4 not equal to what? 0. You can equate each expression to not equal 0, and then you find the value. So from here you can see that x is not equal to what? 4, or x is not equal to what? Negative 4. Okay, so from here the domain is simple. X is such that x is not equal to what? 4 or negative 4. Okay, to represent this on a number line, let's represent this on a number line. You draw your number line, you have your negative infinity to what? Positive infinity. Your numbers or digits are 4 and negative 4. Negative 4 comes on the number line first, and then you have your 4 here. Okay, not equal to. Okay, so you just have an open circle on top of both. So once they are not equal to, it means that you can have values ranging from all the side between negative 4 and 4, and then from above 4. Okay, yeah, so from here your interval notation will simply become, so interval notation will simply become negative infinity to negative 4 union negative 4 to 4 union 4 towards positive infinity. Okay, so I believe this is simple and understandable. Yeah, so let's proceed to our next question. So our next question is the seventh question. It's saying that we should find a domain of f of x is equal to what? X squared minus 3x all over x squared minus 8x plus 15. Okay, so to find the domain of this function is a rational function. This rational function has no square root, hence the condition of a negative number in a square root will not apply here. But our second condition of the presence of a zero in the denominator will apply. So it means that we have to equate our denominator to not equal 0. Okay, else when we have it equal to 0, we'll have an undefined function. That's what we don't want in the domain. Okay, anything that makes the function undefined, it will not be part of our range of values for the domain of the function. Okay, so from here we have a quadratic equation, simply factors of 15 that will add up to give you negative 8 and multiply to give you 15. I'm looking at 3, 5, I'm looking at a negative. So negative 3 times negative 5 will give you 15. And then negative 3 plus negative 5 will give you negative 8. Okay, so we can have x minus 3, x minus 5 not equal to what? 0. And then you take each expression, not equal to 0, x minus 5 not equal to what? 0. So from here you have x is not equal to what? 3, or x is not equal to what? 5. So from here the domain is simply x is such that x is not equal to what? 3 or 5. Okay, or some books can say x is such that x is a member of all real numbers except x is equal to 3 or x is equal to what? 5. Okay, so this is a domain. To represent this on the number line, very simple, like we have been doing. Very simple. To represent this on a number line, you simply 3 and 5. Okay, and then you have an open circle, all ranges of values less than 3, between 3 and 5, and then above what? 5. So if you want to write the interval notation, you can simply write it as negative infinity to 3, not including 3, union 3 to 5, union 5 to what? Infinity. Okay, as simple as it is, I believe as it is understandable. Okay, so that's with the rational type of functions. Okay, let's look at our next type of functions. So we have tackled polynomial functions, we have looked at rational functions without any square roots. Now let's look at radical functions. Okay, let's look at radical functions. Okay, so we are saying that for a radical function of the form nth root of an expression, if n, which is the exponent or the index, is odd, then the domain is x such that x is a member of all real numbers. And if n is even, then we set the function under the square root greater than or equal to 0. Okay, now let me explain what each of these concepts mean. Okay, now we are having a radical function. Radical functions of the form nth root of an expression. We are saying that now if the n, which is the index, is odd, then it means that all real numbers will apply. The domain is all real numbers. This is because now you remember our condition of a function being undefined. The fact that 1, the denominator should not be equal to 0, and then 2, no negative what? Sign under the square root. Okay, the reason why we use squared root is that for a square root has an even index. Okay, but then this one is let's say an odd root. Okay, so for example, for the odd part, now if we have an expression, say third root of 8, right? Now this is the same as 8 to the power 1 over 3, which is the same as 2 to the power 3 in one bracket to an exponent of 1 over 3. And we can say that this will equal to what? 2. Okay. Now for that same odd number, if we have a negative sign inside the square root, inside the root, not the square root, okay, negative sign inside the root, we can see that this is the same as negative 8 to the power 1 over 3, right? Now this can be same as, now if we have negative 8, right, negative 8 is the same as negative 2 times negative 2 times negative 2, because negative 2 times negative 2 will give you 4, times negative 2 to give you what? Negative what? 8. Okay, so it means that we can say that negative 8 is the same as negative 2 to the power what? 3. Okay, so now we have, let's say, a square bracket. We have negative 2 to the power 3 to represent our 8, and then we have what? 1 over 3. 3 cancels 3, and then we have an expression negative 2. Now negative 2 is a defined real number. It's a defined function. It's not undefined. And then 2 is also what? Not undefined. It's a defined function. But then now let's look at for even indexes or even exponents. For example, say we have, let's say, fourth root of what? 16. If you have the fourth root of 16, you know that the 4 is what? Even. So we have an even what? Index. An even index or what? Exponent. Now when we take the fourth root of 16, we know that fourth root of 16 is the same as, can be expressed as 16 to the power what? 1 over 4, which this one can give us 2 to the power what? 4, because 2 to the power 4 will give us what? 16. Okay, now to the power 1 over 4. This can result in the function being what? 2. But then let's say we have a negative value inside a square root, inside a root. Okay, inside like an even root, like 4. Okay, now take your calculator and then punch the fourth root of negative 16. You realize that the value that you get is what? Undefined. Undefined. This is because when you solve this particular equation, you can have, say, negative 16 exponent what? 4. Okay, now you cannot say that negative 16 is the same as negative 2 to the power what? 4, and then come and say that, sorry, let me have 1 over 4 here, and then come and say that this 4 cancel 4, and then you come and get negative 2. No, that's not how we calculate this, because if you take negative 2 exponent 4, you are going to get 16 and not negative 16. Okay, so it means that from here, to solve this particular function, we'll have negative 1 times 16 all under what? 1 over 4. And then our 1 over 4 will affect each of the digits. So this will be the same as negative 1 to the power 1 over 4 times 16 to the power 1 over 4. Then we can say that negative 1 to the power 1 over 4 times 2 to the power 4 into bracket 1 over 4, because 2 to the power 4 is what? 16. Then we can say negative 1 to the power 1 over 4 times 2. Okay, so 2 will come and multiply an undefined function, because when you punch this on your calculator, negative 1 to the power 1 over 4, it is undefined. Hence this whole function is what? Undefined. That is why for every odd index of an expression, every odd index, we are going to have the domain to be all real numbers, because even if you have a negative sign under the root, it's going to result in what? A real number. Unlike, let's say, a square root. For a square root of, let's say, 4 is the same as 4 to the power what? 1 over what? 2, of which 2 is an index, or right, it's an even index. Okay, that is why for even indexes, you cannot have a negative under the square root. Or if you have a negative under the square root, like we said here, you come and get an undefined what? Function. Okay, good. So now the idea is that anytime you see a radical function, you check the index. If the index is odd, the domain is very simple. If the index is even, this is what is going to happen. You are going to set the inside of the equation greater than or equal to what? 0. Because any number which is not greater than or equal to 0 will be a negative number. And if you have a negative number inside and under an even square root, then it means that you're going to have an undefined function. So to stop or not get that undefined function, we'll set the inside function greater than or equal to what? 0. So let's solve some questions so that you can understand what I'm saying better. Okay. So let's solve these questions on radical functions. So for the first one, you have f of x to be equal to third root of what? Negative x plus 5. Okay. Once you see that the index is what? Odd. So you have an odd index because this 3 is an odd what? Index. You simply say that the domain is x such that x is a member of what? All real numbers. Very simple. Or in interval notation, negative infinity to what? Positive infinity. Okay. So it means for all odd indexes, the domain is x such that x is a member of all real numbers. Very simple. Now, with the second equation, the same thing applies. You have f of x to be equal to the fifth root of x squared minus 9. When you check this index, you realize that this index is what? Is an odd index. And since you have an odd index, it means that the domain is simple. X is such that x is a member of what? All real numbers. Okay, good. Now let's look at the next question. The next question is question 3. F of x is equal to square root of what? X minus 9. Now if you look at this expression, you realize that the root is an even index. It has an even index of what? 2, because it's a squared root. Okay, since it has an even index, what we do to find the domain is simply by setting what is inside the root greater than or equal to 0. Because if it is not greater than or equal to 0, we'll have a negative value under the square root. And then once we have a negative value under an even root, we will get undefined. Okay, so we simply set the inside of the function greater than or equal to 0, and then we solve for the value of x. So from here we solve for the value of x. X will be what? Greater than or equal to 9. Okay, so that's our domain. So our domain will simply be x is such that x is greater than or equal to what? 9. Okay, or some books can say that x is such that x is a member of all real numbers except this time. If we have x should be greater than or equal to 9 as our range of values, then the exceptions will be x is less than 9. As simple as ABC. Okay, x is what? Less than 9. So if you are confused with the second approach, you can just go by the first approach. X is such that x is greater than or equal to 9. Okay, but some books will just say x is such that x is a member of real numbers except. Once the except comes, it means that you need to write the values which do not form and do not include in the domain. Okay, and the values that do not include in the domain are the values which are what? Less than 9. Okay, any value which is equal to 9 or greater than 9 is inside the domain. Okay, so this you can represent on a number line. Sorry, I represent on a number line as simply number line. You have negative infinity to what? Infinity. Your value is what? 9. Since you have 9, you see it's greater than or equal to. Once you see greater than or equal to, or you see less than or equal to, then you have a what? You have a closed circle. Some people will say a shaded circle. Why? Because equal to is there. You have equal to 9. Means 9 is what? Included. So you are saying greater than or equal to what? 9. So it's greater or equal to what? 9. So now to write this as an interval notation, guys, notice the trick. Very simple. Now, since we have 9 as a shaded circle, means it's included. So if 9 is included in the interval, we don't use normal parentheses. We use what? Square brackets. And then to infinity, we bring parentheses. The reason why the infinity has parentheses is because infinity can mean any highest number, okay, of which currently we have not defined any highest number, so we just put it in normal parentheses. Okay, so that's how to solve this particular question. Let's solve more questions so that the understanding can become very friendly and easy. Okay, so let's look at the next question. So f of x is equal to square root of x squared plus 3x minus 28. Okay, before we solve this question at this juncture, I'd like you to subscribe to the channel and turn on post notifications so that you don't miss out on any future content. We have a lot of amazing stuff coming your way. All right, so please do want to subscribe. Now let's look at this question. Now we have a radical function, right? And then you notice that since it's a squared root, means that the index is what? 2. And if the index is 2, automatically we know 2 is an even number. So what do we do when we have an even radical function? How do you find the domain? We find the domain by equating what is under the square root to be what? Greater than or equal to what? 0. And this is what? An inequality, quadratic inequality. So you solve it as a quadratic inequality. I believe everybody knows how to solve quadratic inequalities. We simply do this. 28, you find the factors of 28, that will multiply to give you negative 28, and then it will add up to give you 3. I think from here we can identify something like negative 4 and then 7, because negative 4 plus 7 will give you positive 3, and then negative 4 multiplied by 28 will give you negative 4 multiplied by 7 will give you negative 28. Okay, so now we can have x minus 4 and x plus what? 7, so greater than or equal to 0. So each of the expressions greater than or equal to 0, x plus 7 greater than or equal to 0. So this is the trick. Let me teach you the trick to solve quadratic inequalities. So quadratic inequalities, right? Anytime you're finding the value of, let's say, this particular x, if you find, let's say, x, you know x will be greater than or equal to what? The negative 4 will move on to the right hand side of the inequality, and it will become what? Positive 4. Okay, so this will hold. Or anytime you solve and then you move the number to the right hand side of the equation and it becomes negative in this format, for example, x will be greater than or equal to, see, when you move the positive negative, it moves to the other side of the inequality, becomes negative 7. What you do is that you quickly change the sign. So if this is greater than, you come and make it what? Less than or equal to. Okay, you just make it less than or equal to what? Negative 7. Very simple. Don't be confused. When you get a positive, you maintain the sign. When you take the number to the other side of the inequality, you get negative sign. You just change this particular sign. So it was greater than here, change it to what? Less than or equal to what? Negative negative 7. Okay. Okay, so now let's look at the next thing to do. The next thing that we are supposed to do is to just represent this as the domain, right? So the domain is x is such that x is greater than or equal to what, 4, or x is less than or equal to what, negative 7. So that's the domain of this particular function. Okay, or somebody can choose to use the except formula. X is such that x s, you see here, is greater than or equal to, right? So x is a member of all real numbers, except if you have greater than or equal to 4 to be part of the domain, then that means that the portions which are not part of the domain for this one are going to be numbers which are less than 4. All right, or x, once you have less than or greater, less than or equal to negative 7, you're going to have the ones which are the exceptions to be what's greater than what's negative what, 7. Okay, so this is another way of writing it, right? Okay, so let me clean this way, and let me see something. Now, anytime people get an expression like this, they can be forced to say that, to combine these expressions into the notation and say that the value is x is such that negative 7 greater than or equal to x greater than or equal to what, 4. The reason why you cannot, but you, this is wrong, you cannot write it this way. You cannot write it this way. Okay, the reason why you cannot write it this way is that, look at the ideology, look at the analogy. You are saying that x is less than or equal to what, negative 7, right? If a number is less than or equal to negative 7, it means that it can be negative 7, or it can be less than negative 7, which is negative 8, negative 9, negative what, 10, and so forth and so on. And then that same number of which you are saying is less than or equal to negative 7, that same number is greater than or equal to 4. You see, it doesn't make sense. You have 4, 5, 6, 7, and so on. Doesn't make sense, right? So that's why you cannot combine them. So anytime you want to check if you cannot combine them, you can combine them and then check if it makes sense. If it doesn't make sense, it means that you cannot combine them. Okay, this has to do with this particular. So you leave your answer this way. Okay, you can decide to draw it on a number line. Number line is very simple. You have your negative 7 as your lowest value, and you have your 4, right? Now, when you look at the negative 7, it's less than or equal to, once it can be equal to negative 7, you bring your closed circle or your shaded circle. Since they're saying less than, means that it's less than, values go into this way. Okay, now when it comes to the 4, it's also equal to or greater than. Okay, you shade it, so that will be a closed circle. And then they are saying it's greater than or equal to, so since it's greater than or equal to, move forward this way. Okay, so now to write your interval notation, you can simply write it as negative infinity towards negative 7, but since 7 is included, you bring your what, square bracket, union 4. You're saying that since 4 is included, it means that you have to bring a square bracket to square bracket of 4 towards infinity. Okay, this is how to write the interval notation of this particular question. Okay, I believe the understanding is getting clearer and clearer. Okay, we are still on it. By the end of this tutorial or lesson, you'll be able to understand how to find the domain of every single function you come across. Okay, now let's tackle the sixth question. The sixth question is f of x is equal to the square root of x squared plus 4x minus 21. Okay, minus 21. How do we solve this? This is a radical function. The radical function is a square root, means the index is what, 2. And you know that since the index is 2, 2 is an what, even index. And because it's an even index, it means that we have to equate what is inside the um the root greater than or equal to what? 0, because we don't want to have a negative value in the square root. Okay, so we equate is greater than or equal to 0. With the same principle of solving quadratic inequalities, you find your factors of 21. You know factors of 21, 3 and 7. If you have negative 3 plus 7, you get positive 4. Negative 3 multiplied by 7, you get negative 21. So it means that negative 3 and 7 are the right factors. So quickly, you write your factors greater than or equal to 0. Just like I said, the trick to solve this, x minus 3 is greater than or equal to 0. And you have x plus 7 to be greater than or equal to 0. Now from here, x will be greater than or equal to what? 3, positive. Since you have a positive value here, you don't change the signs. But you notice that for this particular one, if you send the 7 to the right hand side of the inequality, you're going to get negative. Since you're going to get negative, you change the sign of the inequality. Then you come and get negative 7. Okay. We are going to learn how to solve quadratic inequalities in another video, and I'm going to explain why you change the sign. Okay. So for now, it's just a trick. Just know it and then apply it when you're solving quadratic inequalities. Okay. Now that we have these, we can since they are all, you can just simply say that okay, x is such that x is greater than or equal to 3, or x is less than or equal to what? Negative 7. Okay. I think you can try as much as possible to write the except one as well. Okay. I believe you'll be able to write it, so I'll not touch on that. Next, you can decide to draw your number line, negative infinity to positive infinity. You have negative 7 and you have 3. When you look at your negative 7, it is part. They are saying that less than or equal to negative 7. So it means that you have what? A closed circle. And they are saying that it's less than or equal to, it means that it goes to the side. Okay. And then for greater than or equal to 3, equal to closed circle, I think that is greater than or equal to it. So it goes this way. Okay. So for this particular one, to write your interval notation, you simply have to write it this way. Okay, since you have this from negative infinity to what? Negative 7, and then it's in a square bracket because negative 7 is included, union square bracket 3 to what? Infinity. Since that 3 is included, we use a what? Square bracket. Okay, I believe the understanding is coming, it's getting clearer. Okay, let's solve our next question with radical functions, and then we can move on to another type of equations, our last type of equations. Okay, so let's solve our seventh question. Our seventh, right? Okay, so our seventh question is f of x is equal to the fourth root of what? 6 minus 2x. So first of all, what we need to do, we need to identify the type of function it is. This type of function is a radical function. Then after identifying the type of function it is, identify the index of the radical function. The index of the radical function is 4. 4 is an even index. Since we have an even index, what do we do to find the domain? We equate what is under the root of the equation greater than or equal to what? 0. So greater than or equal to what? 0. Very simple. So from here we can see that 6 will be greater than or equal to what? 2x. And then from here, divide both sides by 2, you get x to be less than or equal to what? 3. I believe this is a simple math that everyone can do. So from here we can simply say that our domain x is such that x is less than or equal to what? 3. And then from here we can represent this on a number line. You have negative infinity so you have negative infinity to positive what infinity, and then you have 3. We are saying that greater than or equal to. Since you have equal to, it means that you have what? A closed circle or a shaded circle. And then since you are saying that to be less than or equal to, it means that less than or equal to. So it means that for you to write the domain as an interval notation, you can simply write it as negative infinity to 3 with a square bracket, since the 3 is shaded and is included in the region of the domain. So that's how to find the domain of these types of radical functions, where the radical functions are all numerators and they are not in the denominator. You realize that for every function here is a numerator, because you can quickly write each of the functions this way. For f of x, the first one, you can write it as third root of what? Negative x plus 5 all over what? 1. So it means that all of them are just numerators. They are all divided by 1. Okay. Now let's look at the next type of functions we have. Okay. Okay. So our next type of functions are actually fractions with radicals. Okay, fractions with radicals. So don't forget our initial principle of a domain. We are saying that a domain is the range of values that are defined. Okay, and whatever makes the function undefined is not part of the domain. Okay, so now we have, let's look at our first question. Our first question is f of x is equal to square root of x plus 5 all over x squared minus 4. Okay, so we ask ourselves, since we have a fraction, we ask ourselves, okay, is there any value that can make the numerator undefined, and is there any value that can make the denominator what? Undefined. Okay, when you look at the numerator, you realize that this function can be what? Undefined. Can be what? Undefined if we have a negative under the square root. Okay, this means that we can see that, okay, x plus 5, since this one is what? An even index, should be greater than or equal to what? 0. Because if it is not greater than or equal to 0, and then we have a number which is less than the 0, it means that we're going to have a negative what? A negative value under an even index, and that will cause us to have an undefined function. Okay, so this is the first part of the equation. Now the second part is, this is also an equation. If you put, there's a value that when you put here can cause the denominator to be equal to what? 0, and that is one of the conditions that we don't want, right? So if you have a denominator equal to 0, you make the function what? Undefined. So that one will also say that x squared minus 4, that denominator should not also be equal to what? 0. Okay, and then we solve both equations. Okay, so now, sorry for this one, you don't have to bring the square root. What you do is that you put the number under the square root, greater than or equal to what? 0, just like we discussed in the previous questions on radicals. Okay, so this one, the same thing. X plus 5 is greater than or equal to 0. You come and get x to be greater than or equal to what? 5. Okay, then for this side, this is also difference of 2 squares, because x squared minus 2 squared not equal to 0. X minus 2 and x plus 2 not equal to what? 0. So we'll end up getting x minus 2 is not equal to 0. X plus 2 is not equal to what? 0. And then we can come and get x is not equal to 2, or x is not equal to what? Negative 2. Okay. Now we have 3 values. Okay, once we have 3 values, we can quickly conclude on the domain. That is if we have only one greater than or equal to sign. The rest are just equal to signs, not equal to signs. Okay. So from here you can say that simply you can say that the domain is x such that x is greater than or equal to -5 and x is not equal to 2 or -2. Okay, you notice that I said x is such that x is greater than or equal to what? -5. Comma, this comma stands for end. Okay, so end x is not equal to what? 2 or -2. Okay, so you can represent this on a number line. To put this on a number line, you have, let's say, a number line -infinity to what? Infinity, and then you can have your -5, -2, and then what? 2. So the -5, we are saying that greater than or what? Equal to. So you have an what? A closed circle, and then you are saying that it's greater than or what? Equal to. So it moves this way. Okay. Now when it comes to the 2, you have an open because it's not equal to. Okay. Means that these parts are not what? Included. These parts are not included. So it means that if the -2 and 2 are not included, it means that every part here is included. Every part between the -2 and 2 is included, and every part above the 2 is also what? Included. So what you are going to do, you are going to find the intersection of the two different types of equations. So the first one is this side, and the second one is this side. So let me change the first side is this particular line, and then this particular what? Line. Okay. Okay, so from here you can know that the intersection point of this and this is from here going. Okay, so you can simply say that x is such that x is greater than or equal to what? -5, except the 2 points where it is not equal to. Okay, so just want to write the interval notation. You can simply write it as this, right? So you can say, okay, now this region is part, this region is part, and this region is part. Okay, but then these 2 points are not part. So you can see that then it is what? -5 to -2. We are going to use parentheses. We are not going to use square brackets since the -2 is not included. Okay, union -2 to 2, this particular interval, and then our last union from what? 2 to what? Infinity. And that will be our interval notation for this particular question. Let's go through the next type of questions we have so we better understand what we are doing. Okay, as you solve more questions in math, a lot of the concept comes to your fingertips. Okay, so now let's look at the second question. Second question is f of x is equal to 3x minus 4 all over square root of what? X plus 9. So just like I said, once you have a fraction, you check numerator and denominator. What can make the function what? Undefined. Okay, realize that when you look at the numerator, you have 3x minus 4. There is no value that when you put at 3x minus 4 you make the function what? Undefined. Okay, there is no value. You can check which number that when you put inside this particular function can make the function undefined. There is no number as such. Okay, so that means that that side is all raw numbers. So you quickly focus on the lower side of the equation, which is the denominator. Now the denominator, you check is a radical function. Look at the index of the radical function. It's a square, so it means 2. The index is what? 2. And you know that since we have 2 as the index, it is what? An even index. And don't forget what we said about even indexes. With even indexes, we don't want to have zeros. We don't want to have a negative value under the root. Okay, so it means that what we do is that we equate what is under the root to be greater than or equal to 0, because we don't want any negative number, so greater than or equal to what, 0. And then from here you can see that x is greater than or equal to what, -9. So our domain is simple. X is such that x is greater than or equal to what, negative what, 9. Very simple. Very, very, very what, simple. You can draw this on a number line. Very, very simple. -9. Since you have greater than or equal to, since there's equal to, you have a shaded circle or a closed circle. And then since it's greater than or equal to, you can move this way. It means that our interval notation will simply be what, -9, but then with a square bracket to what, infinity. And then that will be all for this particular question. Let's look at our third question. Our third question. Okay, so our third question, we have f of x to be equal to square root of x plus 1 all over square root of what, x squared minus 36. Okay, so just like I said, we have a fraction, right? And then for fractions, what you're supposed to do is that first of all, you're supposed to identify the numerator and denominator and check if any of them can cause the function to be undefined. Look at the first part, which is the numerator. You realize that it is a squared root of x plus 1. It is what, an even root. And you know, for even root, we don't want to see any negative inside. So means that we equate it, what is inside greater than or equal to 0. We also check the denominator, sorry, you realize that there's also an even index of a radical, which is 2. So it means that that side also, you equate it to be what, greater than or equal to you equate that side as well, okay, to be greater than what, 0. So now let us look at this one, right? Now we have gone through indexes that had the numerators, okay. So for here, x plus 1 should be greater than or equal to, sorry, let me remove the square root, greater than, so we have what, x plus 1 to be greater than or equal to what, 0, okay. Because if we have 0 here, it will be 0 plus 1, and then square root of 1 is what, 1, which is defined, okay. But then when you have a radical, please take note of this. When you have a radical in the denominator, for that one, you are equating the radical to be greater than 0 and not greater than or equal to 0. Because if you equate all these things to be what, 0, you have the square root of a negative of 0. The square root of 0, you have 0, right? You have 0 being the denominator. And you know that when you have, let's say, an expression x plus 1 all over 0, makes the function what, undefined. Okay, so since for radical functions at in the denominator, you make it greater than 0. Okay, don't bring the equal to, because if you make it equal to 0, it can also cause the function to be what, undefined. Okay, I believe you are getting the concept. All right. So now we solve these equations separately. Realize that from here you can see that x is greater than or equal to what, negative 1, right? X greater than or equal to -1. And then for this particular side, difference of two squares, you have x squared minus what, 6 squared greater than 0. You have x minus 6, x plus 6 greater than 0, right? So x minus 6 greater than 0, x plus 6 greater than what, 0. Okay, so just like I said, for inequalities, here you get x greater than what, +6. Since it's positive, you don't change the sign. But here, when you send the 6 to the other side of the inequality, you realize that you're coming in -6. So it means that you need to make it, to change the sign to make it what, -6. Okay, now this is it. Now when you notice, you have inequalities being part of all our answers. Okay, so for question types like this, before you declare the domain, you have to first draw it on a number line, okay, to check the points that are intersecting. If there are points which are intersecting, then the intersecting regions are going to be the domain. If all the points are not intersecting at any point, then it means that all of them are the domain, and you have to declare them as unions in domains. Okay, now let me make it understandable. Now for this particular answers, we draw our number line. Okay, now let's draw a number line here. Let's draw a number line here. Now we draw our number line, and then we have -6, -1, and we have what, 6. Okay, now let's try -1 greater than or equal to, so it means that we'll have a closed circle greater than or what, equal to. Okay, so that's for this particular region. Now let's look at x to be greater than 6. Okay, since, sorry, let me clean this number line and let me draw it again. The position of the number line is not healthy, so let me draw it here. -infinity to infinity, then you have your -6, -1, then 6. Okay, now we declared -1 to be this, and then it goes this way. Now when you look at the 6, right, they are saying greater than 6, it means there is an open one, there is no equal to, so it's an open what, circle, and it's greater than, so it moves to this way, right? And then you have -6. Now when you look at your -6, the same thing applies. You have an open circle, and then there is less than what, -6, goes this way, right? Now when you check the 3 lines, line number, let me get this, line number 1, line number 2, line number 3, right? You check if any of them is intersecting. Now when you check, you realize that these 2 lines are intersecting at some point. They're intersecting from here to here. Okay, so that would be the domain of the function where they are intersecting. But notice that they are intersecting though, but then they are not intersecting on the 6 itself, because the 6 is open and is not included as part of the domain. Okay, so from here you can simply say that then the domain is x such that x is greater than what, 6. Very simple, because you know that these are the range. Okay, so the 6 is not included, so it's just greater than what, the 6. So from all this side to what, this side to infinity. Okay, so once greater than 6. Okay, or you can say in interval notation, you can simply say what, 6 to what, infinity. But the 6 will not have a square bracket since it's not included as part of the, what, the domain. Okay, so I believe this is understandable. Okay, now let's tackle our last question when it comes to domain of a function. So you realize that we have solved all the types of domain questions. So if you have any other type that you are finding challenging, you can just drop it in the comment section, and I'll do all to solve it and then upload a video on that. Okay, now we have our last question. Okay, we have f of x to be equal to the square root of the expression x minus 3 all over what, x plus 2. Okay, all over x plus 2. Now let's solve this. Now you notice that this is just one square root, and then you have something, an expression under the square root. Okay, so this is the same as this whole expression is divided by 1. Okay, the same thing. So now what you are supposed to do is that you're supposed to check, okay, this whole thing, this whole expression is a radical function. Okay, you check the index of the radical function. The index of the radical function is a square root, so it's 2, and it's an even index. we have said that when you have any even index, what you should do is that once it is a numerator, all these sides are numerators, because this expression is different from this expression. Okay, so this one, everything is under the square root, so it means that everything is what? A numerator. So what we do is that once the numerator and is a radical with an even index, you equate what is under the radical to be greater than or equal to what? 0. Okay, if the function was, let's say, x minus 3 over square root of x plus 2, then you can equate x plus 2 to be just greater than 0, because it's in the numerator. Okay, but on this side, this time everything is in the numerator. Okay, because the radical is affecting all the functions. Okay, every function. Okay, so x minus 3 is greater than or equal to what? 0. So this is a type of inequality. Okay, and for these types of inequalities, this is how to solve them. Okay, this is how to solve them. Now, to solve them, what you do is that first of all, you take each of the expressions, so x minus 3, and you equate to 0. Okay, now x will be equal to what? 3. Okay, you also take x minus x plus 2, sorry, and you equate to 0, and then you come and get x will be equal to what? -2. Okay, so you have 3, and then you have negative 2. You have 3, and then you have what? -2. Okay, so quickly, what you do is that you put all of them in the number line, then you have -2, and then you have what? You have -2, and then you have what? 3. Okay, so now this is what you this is what you do. Now, for the upper part of the equation, right? Now we are saying that x is equal to 3. Since it is the numerator, okay, we can have x to be equal to 3, because if you put 3 minus 3 to make the numerator what? 0. Okay, which is not going to be undefined, it's going to be defined, right? So it means that 3 can be included with this particular one. All right, but then when you look at the x plus 2 to give you -2, if you put -2 here, you come and get -2 plus 2, which will give you 0. And once the denominator is 0, it makes the function what? Undefined. Okay, so it means that for this particular, you have an open circle. That's how to draw the number line. Okay, so with solving these types of radical functions, use a number line to solve them. Okay, now after you have now drawn the number line this way, now you need to determine which region inside this number line is going to make this equation hold. Okay, so now you identify that there are 3 regions. There's this particular side of the region, there's this particular side of the region, and then there's this particular side. So it's 3 regions. One region, region 2, and then region 3. Okay, so now what we are coming to do is that let me go back with this. Okay, so now we are coming to test the 3 regions and see which one is going to give us winning, and which one is going to give us which one is going to satisfy the equation. Okay, so we're going to check for values, and then we're going to put the values into this equation and check if those values are going to be greater than or equal to 0. So now let's take the first region, this particular region, from 3 to infinity. From 3 to infinity, let's pick any number. So pick any number at all. So let's pick 4. If we pick 4 and we put 4 into this equation, we'll get 4 minus 3 all over what? 4 plus 2. This will give us what? 1 over what? 6. Okay, 1 over 6 is greater than or equal to 0, right? So it means that This region satisfies the equation, so this region is correct. Okay, so that's the first thing you need to take note. So this region is what? Correct. Okay, because the value that we had is greater than or equal to 0. Now let's look at this second region between -2 and 3. Let's pick any number. So me, I'm going to pick 0. You can decide to pick any number at all. When you pick 0 and you put it into the equation, you come and get what? 0 minus 3 all over what? 0 plus 2. Okay, and this is going to give you -3 over 2. -3 over 2, is it greater than or equal to 0? No, because -3 over 2 is what? -1.5. And you know 1.5 is less than 0. It means that this side of the number line doesn't satisfy the equation. So it means that this region is not part of the domain. Okay. Now let's look at the last region, this particular region, from -infinity to -2. Okay. From -infinity to -2, let's pick any number. I'm going to pick -3. Okay. Now, if you pick -3, you can put -3 minus what? 3 all over -3 plus what? 2. -3 minus 3 is what? -6 all over -3 plus 2 is what? -1, which is the same as what? 6. Is 6 greater than or equal to 0? Yes, 6 is greater than or equal to what? 0. It means that the third region also satisfies the domain, or it satisfies the equation. So it means that once it satisfies the equation, those regions are what? Part of the domain. So right now we have identified that this region is part of the domain and this region is what? Part of the domain. Okay, so now we can write our domain. So we can say that the domain X is such that, so now let us write the interval first. Let's use interval notation. Okay, since we have the number line, okay, let's use interval notation first. So now from the interval notation, we can see that the domain is from what? -infinity to what? -2. -infinity to what? -2. Notice that the 2 here is with parentheses, not with a square bracket, because we have an what? Open circle, and it's not included as part of the domain. And then we'll have union what? Our next region which satisfies. This is the region that satisfies, and it starts from 3. But notice that this 3 has what? A closed circle, and hence we can say that we have a square bracket and then 3 to what? Infinity. So this will be our interval notation for our domain. Okay. So simply you can write the domain as X is such that you can say X is such that X is what? From here, this particular interval notation can be written as X is less than what? -2. Okay. Or you can say that X is what? Greater than or equal to what? 3. I believe you have got the concept, because for this one, you know, from -infinity to -2, all the values are less than -2. But then for this one, because the 3 is included, it's greater than or equal to 3. Okay. So that's all on how to find the domain of any type of functions. I believe you have tackled every kind of functions, but then if you identify any functions you feel is challenging, you can put it in the comment section and let's solve. If you found this video helpful, please do what? Give this video a like and subscribe to our channel so you don't miss out on future content.